Rust Nomicon defines lifetimes as the named regions of code that a reference must be valid for. In a local context, we don't need to worry about lifetimes because Rust has enough information to work out everything as optimally as possible. However, once we cross the function boundary, we encounter with the problem of dealing with lifetimes. While the concept of scope exists in other languages, and lifetimes often overlap with scope, they are not the same. Lifetime annotations are unique to Rust programming language. Let's go through an example to understand lifetimes. The official Rust book uses this code to introduce to us the concept of lifetimes. In this block of code, let's refer to the lifetime of R as tick R. In Rust, it's standard to use tick R or tick A or tick followed by a word to declare a lifetime. Let's refer to the lifetime of X as tick X. This part of the code throws an error because X outlives R since it is dropped after the inner closing parentheses and therefore invalid while accessing through R in println macro. While passing the variables to function parameters by reference, we need to take into consideration two important rules. Any reference must have an annotated lifetime. Any reference returned must have a lifetime of one of the reference parameters or it must be static. We will discuss static lifetimes in the next video. This function, foo, runs without any errors due to Elision rules. Elision rules are a set of rules baked into Rust itself, so you don't always have to be verbose about lifetimes. This takes away a lot of work from our end, helping us focus on more meaningful tasks. This, however, does not prevent us from specifying lifetimes. We can edit this code and be more verbose about it. This function is declared for a lifetime tick A. The reference passed into the function parameter has a lifetime of tick A and must live for at least as long as this function call. Let's say we pass another reference named tick Y. Let's assign a lifetime of tick Y to it. Now we must also update our function to include tick Y into its function signature. If X and Y have same lifetimes, then we can use tick A to refer to both references and reduce our function signature to this. Let's go back to tick X and tick Y. If we want to return a reference, we must also annotate that return value with the lifetime of the reference returned. Tick X if we are returning X, or tick Y if we are returning Y. If both X and Y have same lifetimes, then we can also use tick A to annotate the parameters as well as the returning reference. What if our function contains if-else blocks and we do not know ahead of time which value will be returned? Then we use bounds. Similar to generics, we also have bounds for lifetimes. Let's say this function compares the two variables and returns the greater of 2. This function will not compile, and we receive an error that looks something like this. Our function is unaware for how long our return value will be valid for, because we are returning a reference. It can be valid for tick X, or it can be valid for tick Y, depending on whether we return X or whether we return Y. To solve this, we can add a third lifetime for our return value called tick out. We also need to specify that both tick X and tick Y outlive tick out. This means that now we can return references with the lifetime of tick X or tick Y. It does not matter because tick X and tick Y being longer than tick out can be coerced into tick out. If both X and Y had same lifetimes, tick X, then we could have used tick X for the return reference as well, because we know exactly the lifetime of the reference we are returning. Let's take another example. This function, with the lifetime parameter of tick A, throws a compiler error because X is defined inside the function and its lifetime is smaller than the lifetime of tick A, since it is dropped as soon as the function call is over. Therefore, the error that X does not live long enough. Shorter lifetimes cannot be coerced into longer ones. That's it for this video. In the next video, we shall be discussing lifetimes in traits, structs, static lifetimes, and Elision rules. If you have any questions, you can drop them in the comments, and if you would like to read more about lifetimes, I have linked some great Rust articles in the description. Thank you for watching.